Hello students. So in this video we're gonna start with the first chapter. For state board it is first chapter, but for CBSE it is fifth chapter, arithmetic progression. Okay, arithmetic progression, or it can also be called as arithmetic sequence. Okay, both mean the same thing. Okay, a very easy chapter. First let's understand what is a sequence, then we'll get into this. Okay, so there is something called as sequence. Trust me, you have already learned this in your primary classes. If you remember, there was an exercise where when you were very small, a teacher would have given you this triangle, square, let's say circle. Okay, just take it, this is not a perfect circle, just assume it is a circle, then a triangle, then a square, then a circle. What does come next? Definitely you would have solved such problems. Triangle, square, circle, triangle, square, circle. Then what does come next? Triangle itself, isn't it? This is actually a kind of sequence itself. Sequence is basically a pattern involved. There is a pattern involved in it. Okay, where here you can see there is a triangle, square and a circle. It's a pattern, right? It is repeating. Again triangle, square and a circle. Again you'll have triangle, square and a circle. So sequence is basically something, arrangement of something where there is a certain pattern in it. Okay, or the standard way of defining sequences is arrangement of numbers in particular according to a rule. For example, let's say in your school prayer hall, you are made to stand according to your height wise, isn't it? We don't stand however we wish, we stand according to your height wise. So here the students are being arranged according to their height wise. This is also a kind of sequence. So what is sequence? Sequence is simply the arrangement of numbers according to a certain rule in definite order. As I told you, the best example is the arrangement of students in the prayer hall. Let's see some sequence in numbers. Okay, let's say 2, 3, 4, let's say 2, 13, 42, 42, then let's say 55, 69. This is also a sequence and you have learnt it. Could you guess it? If you want, you can pause for a second and you can guess it. Okay, if you have not get it, it's simple. It's just ascending order, small to big. So you are arranging numbers here, arrangement of numbers according to a certain rule. What is the rule over here? Ascending order. What is the rule? Small to big. I've arranged the numbers. This can also be a sequence. Or the reverse, descending order. That can also be a sequence. Or let's take like this: 2, 4, 6, 8, 10, 12, 14, so on. This is also a sequence. I can say sequence of even numbers. Or I can say I've just added 2 to each number. I can also say 1, 3, 5, 7, 9, 11, 13, so on. This is also a sequence. I can say I've added 2 to each number. 1 plus 2, 3. 3 plus 2, 5. 5 plus 2, 7. Or I can say that it is sequence of odd numbers. There are many sequences. Okay. So basically sequences, arrangement of numbers according to a rule. Let's see some more sequence. Okay. let's say 3 4 sorry 3 7 11 15 and so on, it keeps going. Or let's say 1 4 9 16 25 so on. Or let's say 2 4 8 16 32 so on. All these are sequence. There are some rules hidden in it, we have to find it. There is a pattern in it. Okay, let's say 1 let's take 2 9 28 65 so on. There are these, all these are examples for sequence. Here what is the rule? I'm just adding 4. I'm just adding 4 to each term to get the next one. I'm just adding 4. I just took the initial number 3, some number 3. I'm adding 4. 3 plus 4 7, 7 plus 4 11, 11 plus 4 15 and so on. Let's look at this. Now let's see, well, I've added it 1 plus 3 4, okay, but 4 plus 3 is 7, but I've got 9. So I'm not using this rule here. There must be some other rule over here. If you observe carefully, it is 1 square, 2 square, 3 square, 4 square, 5 square, square of natural numbers. That is the rule. Square of natural numbers. And I've done it in a certain order. See, this is square of natural numbers. I have not written it however I wish. I have written it in increasing order. If you observe, 1 square, then 2 square, then 3 square. So in an increasing order, 2, 4, 8, 16, 32. What must be the rule here? Multiplication by 2 for each term. 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32 and so on. This is also a sequence. 2, 9, 28, 65. What must be the rule for this? Observe carefully. I'll leave it as a task for you. Try to find it. What is the rule here? What is the pattern here? Okay. So there are so many sequence. Here we are going to discuss arithmetic sequence or arithmetic progression in your 10th standard. When you get into your higher classes, you'll be learning geometric progression, GP, harmonic progression, HP. There are so many sequence, Fibonacci sequence, there are many sequence, okay. But in your 10th standard, we are going to learn about arithmetic progression or arithmetic sequence, okay. So we got to know what is sequence. Sequence is simply the arrangement of numbers according to a rule, okay. Now, each number in the sequence is called as terms. Each number in the sequence is called as terms. This number is in the first place, so we call it as first term. This is in the second place, so we call it as second term. This is in the third place, so we call it as third term. This is in the fourth place, fourth term, and so on. Fifth place, fifth term, and so on. And we write it as a suffix 1, meaning this is my first term. For second term, we write it as a2, a suffix 2, a3 for third term, and so on, a4, a5. Remember, you have to write it below. That is why I call it as suffix, right? You should not write it as a1 like this. This is wrong. A suffix 1, a suffix 2, like this, okay? So each number in the sequence is called as term. If it is in first place, we call it as first term, second place, second term, third place, third term, and so on. If it is in nth place, some place, I don't know which place, nth place, I call it as nth term, denoted as an. If it is in nth place, I call it as nth term. How do you denote it? A suffix n. Okay. These are basics. Okay. Now let's directly get into the chapter, arithmetic progression. So it is also a sequence. Progression, sequence mean the same. It is a sequence. So there must be a rule in it. Let's find out what is the rule in it. Okay. So let's find out what is the rule in it. So let me write certain sequence. Okay. Let me take few examples. The one which I taken, the first one, let me take it again. 3, 7, 11, 15 and 19, so on. Let's say 2, 4, 6, 8, 10, so on. Let's take another example. 5, 10, 15, 20, so on. Or let's take 10, 8, 6, 4, 2, so on. I've written many sequences. If you carefully observe in each sequence, just focus on this sequence. If I subtract a term, each number in the sequence is called as term, right? Forget the first one, take from the second one, okay? Take a term and subtract to its preceding term. 7 minus 3, 4. 11 minus 7, 4. 15 minus 11, 4. 19 minus 15, 4. There is a same difference. When you subtract it, you are getting same answer. So we call it as common difference. We call it as common difference. Okay. Observe the second one. Same pattern. 4 minus 2, 2. 6 minus 4, 2. 8 minus 6, 2. 10 minus 8, 2. You're getting same answer. Therefore, such kind of sequence are known as AP, arithmetic progression. Meaning, there should be a common difference whenever you subtract a term and its preceding term. Preceding term is simply the previous one. Just observe. Except the first one, because there is nothing behind it, right? There is nothing behind it. I cannot subtract with anything. So, let's start from second one. The second minus first. The third term minus second term. Fourth term minus third term. Fifth term minus fourth term. You're getting the same answer. You're getting a common difference. Even in the second answer, you're getting a common difference. Let's check with the third one. 10 minus 5, 5. 15 minus 10, 5. 20 minus 15, 5. You're getting the same answer. You're getting a common difference. Let's check with this. 8 minus 10, minus 2. 6 minus 8, minus 2. 4 minus 6, minus 2. 2 minus 4, minus 2. As you can see, there is a common difference. If you have got a sequence in this kind, we call it as AP. There must be a common difference. You must get a same answer when you subtract a term and its preceding term. The same thing can be said in another way also. The other way is, if you are adding a same term to get next term. For example, let's take this. How did I get this AP? I took a number 3. Just observe, I am adding a same number again and again to get the next terms. 3 plus 4, 7. 7 plus 4, 11. 11 plus 4, 15. 15 plus 4, 19. Isn't it? The same thing I can say it for this. 2 plus 2, 4. 4 plus 2, 6. 6 plus 2, 8. 8 plus 2, 10. See, I am defining it in two ways. Either you should get common difference. That can be one definition. The same thing can be said in another way. That is, you are adding same thing. You are adding a same number, a fixed number to each term to get the next term. Okay. Here what am I adding? I am adding minus 2. 10 minus 2. 8. 8 minus 2. 6. I am adding it. 10 plus minus 2. So plus into minus is minus. So you get 8. Again to this 8, I am adding minus 2. So plus into minus is minus. You get 6. So for each term, I am adding a fixed term. This is my fixed term. This fixed term is also known as common difference. I am adding a fixed term to each term to get the next term. Okay. So such kind of sequence are known as AP. So I hope everyone got to know whether a given sequence is AP or not. How to find whether a given sequence belongs to AP or not. Okay. Now, as I told you earlier, each number in the sequence is called as term. Right. So first term we write it as A1 or we write it as A. First term we can write it as A1 or we can simply write it as A. This common difference is denoted by small letter d. Okay. A1 is simply first term. I can write it as A1 or I can write it as A also. No problem. This d represents what? Common difference. Okay. These are the notations that I'm going to use in this chapter. Okay. Now, the first thing is, let's take an AP. Let's take a sequence. Let's check whether it is an AP or not. That is the basic thing that you have to know. Simply, I'll construct a sequence. Let me say 10, 20, 30, 45, 50, so on. Let's check whether it is an AP. It is said to be an AP if you have got a common difference. Or in other words, if you are getting each term by adding a fixed term. If you are getting each term by adding a fixed number. Say suppose 10 plus 10, 20, 20 plus 10, 30. So if it has to be AP, then I have to add 30 plus 10, where I should have got 40. Or the best way is usually, how do we check whether it is an AP or not? We just subtract, except the first term, because there is nothing behind it. So second term minus first term, 20 minus 10, 10, 30 minus 20, 10, 45 minus 30, 15. No, they don't have common difference. These two have got, these three have got common difference, but the next one, no. Therefore, this is not an AP. Okay. Throughout, you should have common difference. I cannot tell till here it is AP. Of course, but on the whole problem, whole sequence, it's not an AP. Okay. So this is the main thing. You have to know to check whether the given sequence is AP or not. But our work will be very easy, because in the question itself they'll mention in the given AP, for this AP, for any AP, it will be mentioned it is AP. Okay. Now, how to form an AP? How do you form an AP? You want to form an AP? Very easy. Take any number you wish. Let me take 5. Add a fixed number to each term. I'm going to add 10 to it. 5 plus 10, 15. Again plus 10, 15 plus 10, 25. 25 plus 10, 35. 35 plus 10, 45. This is how you form an AP. You take a number, initial number, which is known as first term, and you keep adding a fixed term to get the next term. Okay. Now, if you observe, there are two types of AP. One is known as finite. Another one is known as infinite. So if you observe here, I can count how many are there, right? 1, 2, 3, 5. Totally there are 5 terms. But in the previous problem, previous example, if you observe, I place this 3 dots. Meaning what? It keeps going. I cannot write everything. So indirectly I am just mentioning it keeps going on. Isn't it? So these kind of APs are infinite, and these where it stops. Okay, it stops, it doesn't stop, right? It keeps going. So it is infinite. It stops. So it is finite. Okay, these are the two different types of AP, finite and infinite. Okay. Let's think about a situation. Say suppose your father is giving you some money for your pocket. Is giving you money. Okay, pocket money. Let's say he gives 5 rupees on day 1. First day is giving you 5 rupees. Next day is going to give you 10 rupees. Next day, the third day is going to give you 15 rupees. That is basically increasing 5 rupees every day. Okay. Fourth day obviously you give 20 rupees. Fifth day 25. Now I'm very curious. What will be the amount that my dad will give me on 98th day? What might be the amount? I'm just curious. Okay, first day he gave me 5 rupees. Second day he gave me 10 rupees. Third day 15 rupees. Fourth day 20 rupees. Fifth day 25 rupees. If I ask you what is sixth day, you will easily say 30 rupees. But if I ask you all of a sudden, what is the amount that you will get on 98th day? You will take time, right? You have to calculate. Okay, 6th day 30, 7th day 35. Okay, you will do it. What if I ask, instead of 98, If I ask you 980th day, or let's say 900, let's say 520th day. Let's make it simple. 520th day. Can you keep counting until you get 520th day? It will take very, very long time, isn't it? So we should have some kind of formula, isn't it, to quickly get the answer. We have a formula. Okay, let's see. The formula is known as nth term of an AP or general term of an AP. Okay, it is given by an, where your an is nth term. Okay, it is in any position. We don't know what exactly position it is. We say it is in nth position. First position, first term. Second position, second term. Third position, third term. If it is in nth position, nth term. That is the logic. Okay. Nth term, it is given by a plus n minus 1 into d. This is the formula. Now you want, what is the amount that you're going to get on 98th day, right? Very simple. Just take out this n and you put 98. If you replace it by 98, what does it become? 98th term, right? That is the amount on 98th day. That is equal to a plus n value is 98 minus 1. A plus 98 in minus 1 is 97. You know the value of a and d. What was the AP? 5, 10, 15, 20 and so on, isn't it? Your a value, a is nothing but the first term. A is nothing but the first term. So your first term is 5 plus 97. Your d is 5. You just subtract it. 10 minus 5, 5. 15 minus 10, 5. 20 minus 5, 5. You're getting common difference as 5, right? Usually we don't subtract everything. Meanwhile, later I'll give you the formula for d. Now this is the common difference, right? 5. Substitute it, calculate it. Very easily you got it. It is way better than calculating each day, right? Pratidina calculate madatkina. To use a formula like this, it is very, very easy, isn't it? You just calculate it, you will get the answer. Suppose you want the answer on 520th day. That's what I said, right? Just replace this n by 520. That's it. Very simple. If you want on 1000th day, still you can get it. Just replace it by 1000. Easily you will get it. Isn't it? So this is the formula where you can use it to find any term that you wish. You want the 50th term, just replace this n by 50. You want the 500th term, just replace it by 500. That's it. Easily you can find it. Okay. So this is the formula, a very important formula. So an is the nth term, a is your first term, d is common difference. Basically n gives you the position, okay, or n can also give you the total number of terms. Okay, we'll come to that later. First let's see how did we get this formula. Okay, I gave you a formula, an is equal to a plus n minus 1 into d. How did we get it? It is very simple thing, so I'm going to derive it. Not important for from the exam point of view, so let's just derive it. So an is equal to a plus n minus 1 into d. Let's say I'll take my first term as a. Let's say I'm going to take my first term as a. Then how do you form an AP? Just now I just explained. You take a first number, then you keep adding a same number to it. 5 plus 3, 8. 8 plus 3, 11. 11 plus 3, 14. So you took a first number and you started adding 3, isn't it? So 5 plus 3, 8. Then 8 plus 3 gave you 11. 11 plus 3 gave you 14. So I'll take my first number to be a and I'll start adding d to it. That is the fixed number that I'm going to add. Here in particular I was adding 3. In general, let me say I'm adding d. Now again, to get the next one, for this I'm going to add d. So it will become a plus 2d. Because there is a d, again if I add a d, it will become a plus 2d. To get the next one, again I have to add d, isn't it? To get the second term, you added 3. To get the third one, again you added 3. To get the fourth one, you added 3. If you want the next one, again you will add 3. 14 plus 3, 17. So this is my first term. I added d to get the second one. Again d, you got the third one. If you add again d, 2d plus d is 3d. Again if you add d. So this was my first term, isn't it? This was my second term, because it will be in the second position, so it is called second term. This is in the third position, so third term, fourth term, and fifth term, and so on. You just observe the pattern. If it is sixth term, definitely, see, I'm going to add d to it, isn't it? So it will become a plus 5d. Just observe, except the first one, in all other thing, there is this a plus, a plus, a plus. A is added to something in each one. So even in our nth term, I can definitely say a is added to something. What is it added to? Just observe. If it is in second position, we call it as second term, right? If it is in second position, second term, we have got 1d. Second term, 1d. Third term, 2d. Fourth term, 3d. Fifth term, 4d. If you observe, in each position, there is 1d less. If it is fifth position, 4d. Sixth position, 5d. Seventh position, 6d. If it is in nth position, 1 less. So it is n minus 1d. That's it. So in each place you got this a plus. A is added to something. What is it to add it? If it is second term, 1 less. There is 2 minus 1 is 1. 1d. Third term, 2d. If it is 10th term, 9d. Okay. So that's how you got the formula. Now you can use this formula or you can use this method which I told you now. It's very simple. If you want 20th term, you just put 20 here. You will get the formula, or it will be definitely a plus, because for every term there is this a plus. Whatever the position, 1 less, 19d. Directly you can write it. Even if you use the formula, same thing you want to get. A20 is equal to a plus, n value is 20. 20 minus 1. Therefore, a20 is equal to a plus 20 minus 1 is 19d. You got the same thing. So directly you can write it. Okay, but if it is for 2 marks, usually for state board students, these kind of questions come for 2 marks. If it is for 2 marks, the formula carries an important role. You have to write the formula. Okay, let's say they have asked you 30th term. So directly you can write it as a plus 29d. When you are solving problems, yes, you can directly take it. You need not write the formula, then substitute, then find it. No, you can directly do it. But in exams, please write the formula. If it is 45th term, a plus 44d. For everything you will have this a plus 1 less, 45 minus 1, 44d. Okay. So far we have discussed what is a sequence. Sequence is basically the arrangement of numbers according to a rule. So what is the rule in AP? You're going to add a fixed term to each term to get the next one. Or you simply, in simple words, you will have a common difference, okay, between the preceding and the succeeding. Okay. Now, there is a formula, very important formula known as nth term. Nth term, an is equal to a plus n minus 1 into d. Okay, there are 4 things here. One is nth term, another one is a, another one is n, and another one is d. Okay. So if you know any 3 of this, you can find the 4th one. For example, you know this value, you know this, you can find the value of d. Usually this is how the problem comes. Or let's say you know the value of a, n and d, you can easily find your nth term. Say suppose you know a and d, you can easily find the value of n. We'll be solving it. Okay. Now, a very, very important point. Throughout this chapter, let it be any problem, one thing that you have to remember is, you should know always the value of a and d. Value of a and d should be known. Okay. That is the very, very, very first step. So, the value of a and d should be known. If you know the value of a and d, easily you can solve the problem. Okay, let it be whatever different kinds of problem. If you know the value of a and d, you can easily solve it. Okay, so everything is based on this. If you know the value of a and b, you can easily solve. If you don't know, how will you find it? Once you find it, you can solve it. Okay, so let's get on to the first exercise of AP chapter.